A recursive sequence is going to be defined using one or more of the previous terms. Now, how this happens is we're given our first term, maybe our first couple of terms, however many it needs to define our general term. So not every sequence is going to be able to be written in this fashion, but some can be. Even some of the explicit sequences and some of our other types of sequences. So for example, the even numbers, we have 2, 4, 6, 8. To be able to write that as a recursive sequence, we have our first term. We're going to call it a sub 1 equals 2. And if we're not having if our first term is not a1, it's a0, so we'd say that as well. We'd say a0 equals. Anyway, so our a1 is going to be 2. Our second term would be a2, and that equals a1 plus 2. And sometimes you're going to want to write out a few of these so that you can figure out what our general recursive term is. So in this case, our general recursive term is a sub n equals the previous term plus 2. So a sub 2 was 2 plus 2. Which equals 4. Our third term, so a sub 3 equals a sub 2 plus 2. So that would be 4 plus 2 is 6. A sub 4 would be a sub 3 plus 2. A sub 3 was 6 plus 2 gives us 8. And so we can keep doing this to find each of our terms based on the previous. Now if we wanted to find, say, the 15th term, we'd have to keep going along until we got to a sub 15. So recursive sequences are not always fun to work with, but it is certainly one way we can look at them. We can do the same thing with the multiples of 5. Just our first term is 5, and then each successive term we're going to add 5 to it. One of the famous recursive sequences, they're seen all over the place, we're going to start with our first two terms. A sub 1 is 1, and a sub 2 is also 1, and then each of our subsequent terms, we're going to add the two previous terms. So we can see 1 plus 1 gives us 2. Then we have 1 plus 2 gives us 3. 2 plus 3 gives us 5. And we can keep doing this to find our following terms. Now we can also have other more complicated things happening, in which case, for example, we have a sub 1 equals 3, and a sub n equals 7 times the previous term plus 4. So let's take a look at what the first 4 terms of this sequence would be. So our first term, a sub 1, is 3. Our second term, a sub 2, is 7 times our first term, so that's 3, plus 4. And so that would be 21 plus 4 is 25. A sub 3 would be 7 times our previous term, which is 25, plus 4. So we see we're already getting pretty big numbers. So 7 times 5 is 35, carry the 3 is 175 plus 4. So it makes it 179. A sub 4 is going to be 7 times 179 plus 4. So a sub 4 equals 1253 plus 4, or 1257. So those would be our first 4 terms of this recursive formula. So 3, 25, 179, and 1257. So you can see that this sequence is growing very quickly, and it might not be easy to see how to make this based on just the numbers we're given. So sometimes when we're trying to write our general term of our sequence, it's going to take a little bit of work. But I hope this helps you with recursive sequences.